Hello everybody, this is Sam Gilk with Bosch Rexroth. Today we're going to be giving an overview of the Firewall application, looking at how you can configure this using the graphical interface in the ctrlX web UI, and then taking a look at a couple real application examples. Let's dive right in. The ctrlX OS Firewall application is a graphical interface to the underlying NFTables subsystem of the Linux kernel. So if you're familiar with that, you'll be right at home here. What this application provides is functionality for routing and filtering of network traffic and interconnecting networks. So you can see some of the core pieces here in this little graphic that's part of the Firewall application. You can see on the left we have the input side and the right the output. In the middle is kind of the local processes running on the ctrlX device. So some of the key options that we have here are input filtering, forward filtering, and output filtering. Input filtering allows you to filter incoming network packets that are directly addressing local processes on the ctrlX device. Output filtering is filtering the output network packets generated by the ctrlX device. And forward filtering is filtering functionality for incoming packets that are targeting some external device but routed through the core. So we'll dive into each of these in a little bit more detail with real examples. The next key area is network address translation. So this is functionality that allows you to interconnect networks. The two main components are what's called destination network address translation and source network address translation. So destination address translation is routing of incoming packets from external devices through the ctrlX device and into an internal device. This will make a lot more sense when we actually look at a real example. And source network address translation is the opposite. So routing of incoming packets that are on the internal network side of the ctrlX device outwards back to an external device. So with that, let's look at some real examples. I think a great place to start with all of this is to consider a pretty typical machine network topology. On the left-hand side here, we have our external network. This might be our plant network, engineering computers, etc. This is routed into our XF10 network interface of the ctrlX core. On the right-hand side, we have our internal machine network. This might be motors and drives, additional controllers. In the example we're going to consider today, it's going to be an Allen Bradley PLC. And as you can see, these two networks are on separate subnets. So we have 192.168.1.1 on the external side, 192.168.2.1 on the internal side. And the question might be, how can we have an external device, like an engineering computer, access a web server on an internal device, like another controller? So we're going to look at that as our example today, and the tools we're going to use to accomplish this are source network address translation and destination network address translation. We're going to start with the source network address translation, which is going to handle the return messages from the internal network device back to our PC. And the way we're going to accomplish this is with a firewall rule, and we're going to set up the external side routing or the destination network address translation actually on our computer at first. So let's get started. All of our firewall tables are built up using three components. These are chains, rules, and expressions. Chains hold a number of rules which ultimately determine where our network packet should be routed, or if it should be accepted, dropped, or rejected in the case of a filter. And each rule is built up using a series of expressions which are evaluated consecutively to determine how that packet should be handled. Each chain has a priority, and this is simply an integer value. The lower the value, the higher the priority. So if you have multiple chains, the lower integer value, meaning higher priority, will be evaluated first. If a network packet happens to match multiple chains, all of them will be evaluated consecutively. So For our example, let's first take a look at configuring a source network address translation chain. I'm going to navigate to our ctrlX Core Web UI. And under Settings and Firewall, I can access the configuration for our source network address translation. We're going to open this up. You'll see that we have options to configure chains for both IPv4 and IPv6 internet protocols. And you'll notice that there's also default chain set up for both IPv4 and IPv6. So it's totally fine if you want to just modify the default chain and add rules here. But for the purpose of this demonstration, I'm going to create a new chain so that we can demonstrate the priority functionality. So by default here, I'm assigned a priority of 0, which means this chain will be evaluated before the default chain. If I set this to some value like 200, the demo chain would be evaluated after the default chain. So let's move this back to 0 so that we evaluate this first, and let's begin to add a rule. So our source network address translation, like I mentioned, is going to handle the return messages from our internal network devices outward to our external network. I'm going to call the rule then PC or PLC back to PC. Within our rule, we're going to add two expressions. You can do that using this button here. And the first one we're going to do is the source NAT expression. So we want any returning packets to be routed through the IP address of our XF51 interface. That's all we have to do. We could also specify specific ports. If you leave this blank, it's going to handle all ports. And the next expression is going to be match packet payload. So we want any IP protocol message with the destination address equal to the IP address of our internal network device. In this case, it's the Allen Bradley PLC, to be routed back through 192.168.2.1, which is our XF51 interface. So we're getting an error here that says statement after terminal statement has no effect. And that's because the source network address translation expression needs to be the final expression in the rule. Now, if we hit OK and save our firewall configuration, that chain should now be applied to any network packets passing through our ctrlX core. So the next step is going to be setting up the incoming side. So how do we actually get our message from our engineering PC to the internal network device? So now that we have our source network address translation configured on the ctrlX core, we can go ahead and set up a route on our engineering PC that will allow us to target an internal network device to the ctrlX machine network from the outside world. So to do that, I'm going to open up an administrator command prompt on my engineering PC, and I'm going to first look at the existing routes. And as you can see here, there's no network destination that is matching the 192.168.2.0 subnet of our Rockwell PLC. So I'm going to go ahead and add a route. And I do this using the command below here, route add, and then I have my target subnet with the subnet mask, and then the IP address that I want to pass through. In this case, 192.168.1.100 is the static IP address configured on the XF10 external network interface of my ctrlX core. Before I do this, actually, I'll just show you that I cannot ping through to the internal network device. You can see the destination hostnet is unreachable. And now if I add that route, I can hit that endpoint. Okay, so now that we have this route established on our PC, I should also be able to access any web server or otherwise running on this internal device. So if I open up Studio 5000, I should be able to target directly this device now. And once this connection has been made, there's obviously some problem here. Oh, now it's been discovered. So now I should be able to go online and I can access the programming interface of this PLC through my ctrlX core in the architecture that I displayed previously, which is here. So we now have this working, only using a source network address translation rule on the ctrlX core. In the next section here, I'm going to show how we can set up destination network address translation on the ctrlX core so that we don't have to manage any routes on the external device. So I've gone ahead and removed the route on my PC that targets the ctrlX core XF10 interface and allows me to access the internal network device. As you can see here, there's no longer a network destination on the 192.168.2.0 subnet. So what we can do now is add a DNAT rule on the ctrlX core, also under our firewall settings, destination NAT. I'll create a new IPv4 chain here, and I'll just call this demo. I'll leave it at priority 0 and create a rule. And this rule is going to handle the PC to the PLC routing. And then I will add an expression. So any IP protocol payload with a destination address equal to 192.168.1.101, and I'll show you in a second, this is an additional static IP address that I've configured on my XF10 network interface. So I'm going to essentially use this as a publicly available target address for my external network devices. So any payload that is targeting this address, I want to destination network address translate it to my actual internal subnet target device IP address. And I can do this on all ports. It's fine for now. Okay, and that should be all that we need for our destination NAT rule. Before we test this, I'll save the firewall configuration, and I'll quickly show the configuration of our network interfaces. So we have XF10, which is our external network interface. And as you can see, I have a dynamic address here, and I have 2 static IP addresses. So using this technique, you would have a separate static IP address for each internal network device that you would like to target. So in this case, we have 192.168.1.101. Another important note is you'll need IP forwarding enabled both on your internal and external network interfaces. So that will be XF51. I also have IP forwarding enabled, and this just has a static IP address of 192.168.2.1. So now that I have this all configured, I will open up my Studio 5000 Designer, and I should be able now to target this device. So you can see here it says 192.168.1.101, and then in brackets 192.168.2.20. So that this is the public address that I'm targeting, and it is being interconnected and routed through to the local IP address 192.168.2.20. So at this point, I should be able to go online with this device. Sorry for the technical difficulties. I clicked on the wrong path and had to wait for a timeout there. So now that I have the right path selected, I can go online. And as you can see, I am now online with this controller, which is sitting internal to my ctrlX core, and I'm accessing this from an external device on a separate subnet. So now that we've connected our external network to our internal machine network using the ctrlX core firewall tables, let's take a look at how you might provide a little bit of simple security on this connection. So the example I'm going to give is just a basic whitelist using the input filter. So I've come to our firewall configuration. I'll select input filter. And in this case, I'm just going to modify the default chain to show you that that will work as well. Instead of creating a new chain, I will edit this. And what I want to do is actually change my default policy to drop. But you'll see here when I try and select this, the chain does not contain any rules with an accept action. So you could not reach the system at all if the default policy was dropped. So before we can do that, we need to add a rule that will accept packets. So I'm just going to call this rule whitelist, and then I'm going to add an expression. And what this is going to specify are the whitelisted IP addresses that I'd like to allow to access my ctrlX core device. So all I'm going to do is say IP protocol, the source address field should equal, and then I can either provide a range or a specific IP address. So let's just say I want my whitelisted IP address to be 192.168.1.20. Okay. And now as soon as I apply this, I'll also switch my default policy to drop so that any other connections that do not match this rule will be dropped. So now what you'll see is that I'm no longer able to access the web interface. So just to verify that, I'll try and navigate back to the homepage of the web UI. And you can see that I cannot access this. And that is because my current IP address is not 192.168.1.20. So in order to modify that, I'm going to come to edit my network settings on my PC. Going to configure my, edit my adapter options here and set a static IP address that is equal to my whitelist IP address. And once I apply this, I hopefully should be able to reach my web UI again. And there you can see that I'm now back on my web UI. And this will be the only IP address that will be accepted to make this connection to my web UI. In this next example, let's consider the situation that we only want a single external IP address to be able to communicate with a single internal network device IP address. We can accomplish this using what's called a forward filter. And we can access our forward filter configuration within our firewall settings. I'll select forward filter. And just as a side note, I did go ahead and remove the input filter table that we configured in the previous section, just so I can demonstrate the functionality of the forward filter without considering those rules. So again, I'm just going to modify our default chain and add two rules, one for the incoming and one for the outgoing packets. So first, I'm going to call the first rule whitelist incoming. And each of these rules is going to have two expressions. They're going to match the packet payload that our source address for the incoming packets is the IP address of our PC. And if you remember in the previous section that we statically configured this to 192.168.1.20. Additionally, we want a second expression that our destination address is the static IP address of the internal network device that we're trying to target. So that's 192.168.2.20 for the PLC. And that concludes the first rule. If both of those expressions are matched, that packet will be accepted through the control. Now we're going to add a second rule, which is our whitelist for outgoing packets. Again, we're going to have two expressions, and all we're going to do in this case is flip-flop our source and destination addresses. So we have now 192.168.2.20 as our source, and 192.168.1.20 as our destination, and that will target our PC. So that's going from the PLC through our controller into our PC as the destination. So if either of those rules are matched, then we will accept the packets. And again, we want to then change our default policy to drop any forward filtering. Okay, so we'll save and apply the firewall configuration, and then we should be able to make a connection through our control to our PLC. So I'll try and go online here. Again, a few more technical difficulties with the path selection, but as you can see, I'm now online with this controller. So if we go back to our firewall configuration and edit, for example, the source address on our whitelist here to some other value, you should see that we are then no longer able to establish a connection with the internal device. So if I save these, and I come back to my Studio 5000 application, it's actually frozen here as it's timing out, losing connection to that device. So I'll give it a second, otherwise I'll fast forward a little bit. Oh, there's our message we were looking for. Can't communicate with the Linux communication software. So that concludes this example. As a final example, I'm going to look at the output filter. So in this demonstration here, I have a node-read flow where I'm simply issuing a ping command from my ctrlX core outwards to another device on my external network, which is a separate PC here at 192.168.1.26. So if I issue this command, you can see that the ping is returned in my debug window here. Now, if I want to restrict which addresses or ports my outbound connections from my ctrlX core have access to, I can use an output filter. I'll select this in my firewall configuration, go to my IPv4 table, and I will edit the default chain. I'll add a new rule here, and I'll call this blacklist. So I don't want my core to be able to speak with these addresses, and I want the packets to be rejected if they match these expressions here. So all I'm going to do is check if the destination address, the address that the ctrlX core output packet is targeting, is equal to the IP address of my external network device. I'll save that rule, update my firewall configuration, and now if I come back to my node-read flow, issue my ping, I should see that this packet was rejected by the ctrlX core output filter. To close out this video, I'm going to demonstrate how you can back up and restore your firewall configuration. The firewall application participates in the ctrlX OS Solutions Manager. So if we come to Manage App Data using this button at the top of the web UI here, we can see that we have firewall configuration data, and we can actually view in the browser the nftables configuration file. So I will go ahead and make a backup of this app data using the Save to Archive button under Manage App Data. And I will call this Firewall Demo. And what this does is save all of the configuration data for every application. You can also download just the firewall configuration file from the browser here. But we successfully created this firewall demo archive, and I will go and make a change to our firewall configuration. Just add some random rule here to our input filter. Save that configuration. And we can see that that rule now exists on the default chain of the input filter. So now, if I go back to manage my app data, I can apply the previously made firewall demo configuration backup. I'll load this archive, and the app data will be overwritten to the active configuration on the controller. Once this completes the upload, I can go back to our firewall and view the rules to see that the previous configuration was applied. So if I come back to my firewall settings, input filter, edit the default chain, that rule that we created is no longer there. That concludes our video overview on the ctrlX OS firewall application. If you have any questions or comments, please reach out in the ctrlX development community.